circle the types of waves that are mechanical waves. We talked about what mechanical waves are. Mechanical waves are waves that have to travel through a medium, a substance.
Sound.
Okay, so what are our choices?
Sound.
Sound waves, yeah, sound wave is an example of a mechanical wave.
Ocean.
Ocean, yeah.
No.
Okay, we've got one more here that I can see. Seismic.
Seismic.
Yeah, those are earthquakes. They'll go through the earth. Seismic waves travel through the earth. So light waves are not mechanical waves?
No.
No? Radio waves are not mechanical waves? No. Okay, very good. Okay, circle the types of waves that are electromagnetic waves.
Microwaves.
Microwaves.
Okay.
What's an oscillating string?
Light and radio.
Anybody can light and radio. Yeah, you got it. Anybody know what an oscillating string is?
No.
No? If I was playing guitar and I plucked a guitar string and it shook back and forth, that means it's oscillating.
So it'd be oscillating string too?
Well, that would be, the string would the string be a medium that the vibrations or that the waves are running through? So does that make it a electromagnetic wave?
Yeah. No, wait, no. I'm not sure.
Not sure. Okay, so the wave, so we pluck a string and it makes a sound, right? So what kind of wave does that make?
Sound wave?
A sound wave.
Sound
Is a sound
wave,
wave electromagnetic wave or is it a mechanical wave?
Mechanical.
So an oscillating string would it or would it not be an electromagnetic wave?
Not.
It would not. So we don't underline oscillating wave. Very good. Okay, an ocean wave is an example of is it a transverse wave?
No.
Okay, is it a wave goodbye?
No. Really?
Electromagnetic wave?
Yes.
Really? No, wait.
Wait. Transfer wave.
It's a what?
A transfer wave.
Transverse wave? Why is an ocean wave a transverse wave? Because it goes up and down. Okay, remember our spring?
Yeah.
Yeah, that's like an ocean wave.
The
Okay.
hokey pokey.
The hokey pokey is the right answer.
The hokey.
Okay, so a wave of in the ocean is an example of a transverse wave. Okay, a sound wave is an example of is it an electromagnetic wave?
No.
No. Is it a wave goodbye?
No.
Is it a longitudinal wave?
Yeah.
Okay, why is a sound wave a longitudinal wave? Anybody know?
Because it's got to go through the air.
Well, that would make it a mechanical wave. What was our example with the spring? It compressed.
Compressed
It
wave.
decompressed.
Yeah.
So a compression wave is another word for a longitudinal wave. And when I talk, it compresses the air really rapidly and decompresses it. So a sound wave is an example of a longitudinal wave. Okay, we got through the first part. Everybody filled theirs out. Everybody put your name on both pages, please, so I can keep track of them.
Activity.
Okay, an activity. Everybody gets one of these.
Yay.
Okay. What color you want? Orange or yellow?
Red is my favorite, please. Red.
Oh, sorry. Okay.
I'll take yellow.
Just grab one. Grab one you want.
I got the last red.
Okay, Montana, you got orange or yellow?
No.
Okay,
Can I have yellow?
so
No.
we're going to make a representation of a wave. Are we still recording? Okay. Okay, so now when we were making our example of a wave with a big long spring, it was kind of hard to just really visualize it because it was constantly moving, right?
Yeah.
So we're going to use these big long pipe cleaners to make a wave. Okay, well, let's twist it back together.
They twist together?
Yeah, and let's not pull them apart again. Like this. Okay? There. All right, so I'm going to make an example of a wave, a representation of a wave, by folding here. And I'm going to make even folds all the way down like this. Yeah, you can do that. And it doesn't matter how long, like this. And then I'm going to spread it out like that. And now I've got what looks like a wave, right?
Yeah, like those.
How's that?
Those like little green things that like.
Yeah, that's
like on
an
the radio?
oscilloscope.
Yeah.
You're talking about an oscilloscope. Very good. You made an excellent connection there. Okay, now, if I lay this ruler across the center of these waves, now I got what is my rest point right here. Now, if I measure from the rest point to the top of a wave where the crest is, everybody knows the top is the crest of the wave, right?
Yep.
Can you all say that?
The crest
Crest
of
of the
the top
wave.
is the crest of the
And
wave.
if I measure it, and I'm going to measure it in centimeters because that's the scientific weight, it's 4 centimeters high. So the amplitude is the height of the wave from the rest point, or down to the trough from the rest point.
Oh, honey,
That's
look how
called the
many I cut.
amplitude of the wave. I've got a 4 centimeter amplitude.
Look how many
Now,
I
if
cut.
I register from, say, the top to the top, that's my wavelength. This is 6.5 centimeters.
Oh, yeah.
I can also measure from the trough to the trough. That's still 6.5 centimeters. So, the height of my wave is the amplitude. Can everyone say that? Amplitude.
Amplitude.
And the length from a crest to crest is the wavelength. Can everyone say wavelength?
Wavelength.
Okay, so everyone make a wave. Are you ready with the wave? Who's
I'm
ready with the
ready.
wave? Okay, let's lay this across here like that. And there's our rest point.
There we
Now
go.
go ahead and measure your amplitude.
Amplitude 4 inches.
No, those are centimeters.
Wait, no, that's centimeters. About 4 centimeters.
Okay, so right down here
Is
and measure from crest to crest.
5 centimeters.
5 centimeters. So go ahead and measure your amplitude to the top of the crest. Here, it'll be easier to read if you move it over just a bit. Okay, so how high is that?
1.5 inches.
1.5 centimeters. We're measuring in centimeters. So go ahead and put W1 for our first wave, and then put A equals 1.5 centimeters. Okay, and now let's measure the wavelength from crest to crest. Okay, I'll go down and I'll help everyone. Crest to crest. Measure the crest to crest. And we'll do 4.5 centimeters. So we're going to measure in centimeters because that's the scientific way. What's it say there?
No, here.
2 centimeters. And now the wavelength. It'll be from crest to crest. So go ahead and measure crest to crest. That will be your wavelength. Say 1, 2, 3, 4, and looks like a half. See, it's between 4 and 5. Okay. How many centimeters is that?
Can you get the dog?
From the top there to the rest
No.
point.
He's staying
1,
He's staying
2,
upstairs.
3. So your amplitude is 3 centimeters. Okay, go ahead. Ready? Count out. 1. Looks like it's halfway between 4 and 5 there, so it's 4.5 centimeters, right? Okay, put down W equals 4.5. Okay, excellent. Good job, everybody. Did we have fun learning about waves?
Yay!
Okay, what did we learn about waves?
Science.
Lots of stuff. Electromagnetic waves.
Transverse waves and longitudinal waves.
And electromagnetic waves.
Okay, what's the difference between a mechanical wave and an electromagnetic wave?
Electric is light.
Okay,
And it doesn't have to go. It doesn't have to go through things.
Yeah.
that's exactly right. Good
and-
job,
And
Rico.
mechanical things go up or down or side to side.
Well, all waves can go up or down.
They have to go. They have to go through different.
A mechanical wave has to go through things, and electromagnetic waves don't need a medium to travel. Okay, let's demonstrate a transverse wave by doing the wave. Yes! Good job!